Hello everyone, welcome back to the channel. In today's video, we are going to build something really exciting, a completely local AI powered QA automation engineer. By the end of this tutorial, you will have an AI assistant that can run completely on your machine, use a free LLM locally with Ollama, interact through LibreChat, control a real browser using Playwright MCP, execute browser automation using natural language. And the best part, no OpenAI API key is required. Everything runs locally. If you are interested in AI for software testing, browser automation, Playwright, MCP, or building AI agents, this tutorial is for you. Let's first understand the architecture diagram. We have four different components: LibreChat, Qwen3, Playwright MCP, and Chrome browser. Everything starts with the user. We type a prompt into LibreChat. For example, open the Playwright website and click the Get Started button. LibreChat acts as the chat interface where we interact with our AI assistant. Instead of executing the request itself, it sends the prompt to our locally running large language model, that is Qwen3 8B, which is hosted using Ollama. Qwen3 8B reads the prompt, understands what the user wants, and creates a step-by-step execution plan. Rather than controlling the browser directly, it decides which tools needs to be used and sends those instructions through the Model Context Protocol or MCP. These MCP requests are received by Playwright MCP server. The server acts as a bridge between AI model and the browser. It translates the AI's instruction into Playwright commands. The Playwright MCP server then launches a Chrome browser and begins performing the requested actions. It can open websites, click buttons, fill forms, read text from web pages, capture screenshots, and perform many other browser automation tasks. Once the browser finishes executing the requested actions, the execution results are then sent back to Qwen3 8B, the LLM. The language model analyzes the information and converts the technical browser output into a clear, human-readable response. Finally, LibreChat displays that response to the user. So instead of seeing a raw Playwright logs, we receive a concise summary such as navigation completed successfully, the Playwright website was opened, and the Get Started button was clicked successfully. This architecture allows us to control a web browser using natural language while keeping everything running locally, providing better privacy and full control over the entire automation workflow. System requirements: a computer with at least 16 GB RAM or more, and it should have a sufficient storage space with a free disk space of around like 20-25 GB. It is recommended to have a SSD. GPU is also recommended for faster model inference, but it is optional. I am currently using Mac OS M2 Pro with 16 GB RAM. This setup also works on Windows and Linux, provided you have the required system with the configurations. Prerequisites. Before we begin, make sure you have Docker Desktop, Node.js 20 or higher, Git, and Ollama. Docker Desktop, Node.js, and Git are commonly used softwares, and you can find the installation steps easily on the internet. I'll cover installing Ollama in this tutorial. So let's start building. The first step is to install Ollama. Ollama can be installed easily by running this curl command in the terminal directly. There is another approach for Mac OS. So you can type in the command brew install Ollama and it will install Ollama. Once the installation is successful, you can run the command Ollama serve to check that Ollama has been installed successfully. After the installation of Ollama is complete, we can move ahead and install the large language model Qwen3 8B. We need to run the command Ollama serve. Ollama serve is already running. It's important to have this Ollama serve running in one terminal so we can use Ollama easily and smoothly. We need to run the command Ollama pull Qwen3 8B. It will pull the large language model. It will take some time. It is around 5.2 or 5.5 GB. So depending upon the internet connection that you have, it will take some time to pull the model. Once you have pulled the model, you can run the command Ollama list to check if the model has been pulled successfully. And you can see after running Ollama list command, I can see Qwen3 8B model has been listed and it shows the details. We can test the model by running the command Ollama run Qwen3 8b, and it will show a message to start chatting with the model. And we can send a prompt like, for example, what is 2 plus 2, just to verify it works or not. You can see the model has started working. It is thinking about the prompt that we sent, and it has provided us with the answer also, 2 plus 2 equal to 4. Under the hood, it did this lot of thinking about the prompt that we sent, and finally it gave us the output. To stop this, we can run /bye by. That will stop the Qwen3 models that we ran with Ollama, but Ollama serve is already running there. To stop Ollama serve, you need to press Ctrl C and it will stop. The next step is to install LibreChat. We need to visit the LibreChat GitHub repository and clone this repository. We can just click on this code and copy the command, and accordingly in the terminal we can run this command for cloning the repository, git clone, and then it will clone that repository. I have already cloned this repository, so I need not run this command again. Let me open VS Code and show you the cloned repository for LibreChat. So this is the repository that I have just cloned from LibreChat. So they have already provided a environment example file. We can just copy this file and create a new .env file. Once the env file is created, let's open it. There's no need to make any change here in the .env file, because we will be using the default configurations for the environment variable that is provided by LibreChat. It's necessary to have this .env file in the root folder. Otherwise, the Docker Compose for the LibreChat won't work. Next, we need to create the LibreChat YAML file. They have already provided the LibreChat YAML file as an example in the repository. Once you clone that, you will be having this file in your local as well. So we need to run the same command, cp librechat.example.yaml and then librechat.yaml. So it will create a LibreChat YAML file for you using the example file itself. And then we need to make the necessary configuration changes, because we need to connect Ollama to LibreChat. So I have already done the changes here, and you can see for Ollama, I have added this configuration settings. The name has been set to Ollama API key, and then the base URL has been set to host.docker.internal:11434/v1. This is where our Ollama is running, and we need to add the models default Qwen3 8b. If you have multiple models, you can list it here, and once you set it fetch equal to true, once the LibreChat application is started, it will fetch all the models that are listed in this configuration for Ollama, so you can accordingly choose the model that you want. But since I have already one model installed currently, I have listed it here and kept the settings at fetch true. All remains the same, and this is the name that will be showing in the LibreChat for the model. So it's Ollama, but inside that we will be having this Qwen3 8b. Here, one more important thing to note is the base URL I have set it to host.docker.internal, because LibreChat is running inside a Docker container. Ollama is running directly on the MacBook, the host machine, this particular machine. And from inside a Docker container, the local host refers to the container itself, not the Mac. So host.docker.internal is a special DNS name provided by Docker Desktop that lets container reach services running on the host operating system. Once you have added the configurations for Ollama in the librechat.yaml, we can mount the configuration in Docker Compose override. In the services block, we can have this volume set to mount this LibreChat. Once this configuration is complete, we are ready to start LibreChat. So let me first start Ollama. We need to have this Ollama serve running in the background. Otherwise, we will not be able to see the Ollama model in the LibreChat. So For starting LibreChat, we need to run Docker compose up -d. It will start all the Docker compose containers in detached mode. I have already pulled all the images previously for LibreChat. That is the reason why it did not take much time. But for you, it might take initially a few minutes, depending upon the internet connection that you have, and all the particular containers will be started. To check the logs, you can see to list all the containers first. You can run the command docker ps-a, and here you can find out if the containers are already started or is there any issue while starting the container. It will show us the details here, and you can see restarting this all containers are already started. It is restarting this admin panel to check the logs. And one more important point here is this is the name of the container, LibreChat. Maybe you can just check out by listing docker ps-a. So this LibreChat container is of most important, the main container. To check its log, we can run the command docker logs librechat-f. And you can see there is some error printing out. This is related to the Playwright MCP. Since I have not started the MCP server in my local yet, I need to show you the configuration settings and then I'll start this. So we can ignore this error for now. But for other things, we can check out. It already shows us the details for starting the containers related to the LibreChat. So let's quickly navigate to the browser and start localhost 3080. This is the URL where our LibreChat will get started. Since I have already been using LibreChat, that is the reason why it directly started with the logged in user. But for you, it will show this kind of a screen where you need to first sign up, add your full name, email ID, password, and confirm password. Make sure you add a correct password here. Maybe the easy one which you can remember. Otherwise, you'll have to create a new login again. Since I have already created a user, I can just use my credentials and login. Once you register and log in, you will be by default seeing this GPT 5.5 model, which you need to change to use the local model of Ollama Qwen3 8B. So you can do that by clicking on this model name, going on Ollama and then selecting the Qwen3 8B model. Now you have successfully selected the Qwen3 8B model, which we have set up through Ollama and is running locally on our machine. Let's verify if it is working or not. So let me ask a question like explain Playwright. And it will take some time to run since we are running this in our local machine. That it depends upon the resources that we are having on the machine, the RAM, GPU, everything takes into the account. And based on that, it will provide us the output. We can just check the Ollama serve window terminal. It should display some processes there continuously as requests that we have sent. It will be passing on through the Ollama to the LLM model, and then it will provide us with the answer. So you can see Ollama has responded like Playwright is an open source browser automation tool developed by Microsoft. It is provided us with the key features and the core concepts. Playwright has CLI use cases. It's still writing something, the example code. Since we have not trained this model to provide us with the what all things that we need, it will provide everything that it has in its memory about Playwright. So that is the reason why it's important to train the model before you start using it. And after that, and then finally, it has provided us with the details to how we can get started, like using npm install Playwright. And then it has provided us some statements like Playwright is ideal for developers and testers looking for modern, efficient, and scalable solution for browser automation and so on. If you want, we can send another prompt. I think it is fine to ensure that the Qwen3 model is connected successfully with LibreChat and it's providing us with the output. Let's move to the next step and install Playwright MCP. So for doing that, we can run this command npx@playwright/mcp@latest and then host allowed host port. By default, Playwright MCP listens only on local host, which means applications running inside Docker containers like LibreChat cannot connect to it. Using --host 0.0.0 makes the server accessible from Docker containers, while --allowed -host with asterisk allows requests from host.docker.internal instead of restricting access to the local host. So if you do not add these two things, it will deny the access to the Playwright MCP from the LibreChat. That is the reason why I've added this, and we can just press enter to start this MCP server. Once the server is started, there's a message displayed here. For legacy SSE transport support, you can use /SSE endpoint instead. We will be using this since LibreChat does not connect to the MCP transport support yet. I tried it multiple times, but it failed. So we will be using host.docker.internal :8931 with SSE, and we will use the transport support of SSE for it. Let me show you how we can configure Playwright MCP in LibreChat. Let's open the LibreChat YAML file and search for MCP servers. I have already added a Playwright server here. You can see the Playwright server is already started, and inside LibreChat.yaml, there is a block for MCP servers. I have added Playwright type. This is the transport support SSE. URL is set to host.docker.internal :8931/SSE. The timeout is also given. So in case if we face any connectivity issues, this timeout will handle it. Next important thing is to check for the MCP settings. Here we need to make sure that we provide this allowed domains property with host.docker.internal :8931 and localhost 8931. Once the setting is done, you need to restart the containers. So let me stop this. Docker compose down. It will stop all the containers, and then do a start again by writing the command docker compose up -d. To check if the LibreChat has been successfully started without any errors, we can check out the errors from the logs using docker logs LibreChat -f. And here you can see everything is green. At the last statement, it says creating SSE transport for this. That means the Playwright MCP server has been connected successfully on LibreChat. Let's add the Playwright MCP server on LibreChat UI. You need to click on this icon MCP settings, click on this plus button, write the name of the server, Playwright MCP server. If you want, you can write the description as well, Playwright MCP server. This is the most important thing. We need to provide the URL http host.docker.internal :8931/SSE. The transport should be SSE, and authentication is none. I trust this application. Check this checkbox. Click on create. And you can see MCP server has been created successfully. The server has been created successfully, but it is not yet attached. So we need to connect by clicking on this icon here. And you see MCP server initialized successfully. Now let's go back to the logs, and you should see something like successfully established connection for Playwright MCP server. This ensures that LibreChat is now correctly accessing the Playwright MCP server. Let's open a new window and use this Playwright MCP server. Just to verify that the Playwright MCP server connection is successful, we will write open http playwright.dev, verify the page title. You need to make sure the model is selected correctly, and this Playwright MCP server, it has a green dot here with this checkbox ticked. And let's send the prompt. After this, you should be seeing this SEC transport message again, and you should see some logs coming up for the Ollama serve as well. If everything is successful, you should see a Chrome browser coming up after running the Playwright commands from MCP server to start that Chrome browser, navigate to that link, and then perform the page title verification. But this will take some time as we are running on the local machine. It depends upon the configuration. Though I have a 16 GB RAM, but sometimes it takes time to start that tool. But if you have more RAM, memory, and a good GPU machine, it will be bit faster. One thing to note here is we have not provided any instructions to AI, so there might be chances for hallucinations here. But for this test, it's manageable for now. Let's see the outcome, what it does, and how it connects with the Playwright MCP server. And you can see there is a navigate command coming up. It's running the browser navigate, and the Chrome browser has started, and it navigated correctly to playwright.dev, and it's evaluating now. But there are some mistakes here. It will fix it on its own. And like I said, there are chances of hallucinations and incorrect output because we have not provided any instructions to the AI, the LLM model, as well as to the server. So as we have not provided any instructions to the server, it will keep on evaluating the things until it finds a logical output. The basic case to test here was to check if the connection happens successfully, and we can see the Playwright commands used from the tools in the MCP server. So we can see that the browser opened successfully using this browser navigate command from the Playwright MCP server. So it's fine now. We can stop this and close the browser as well. Next, let me show you how we can create a new agent with all the instructions and the details so that we can use it for automation testing. So click on this agent builder and write a name like local AI automation engineer. You can give any name here. I'll check the category to research and development. I'll come back to these instructions, but let's first set the model details. We'll set the temperature to 0.1. Ideal temperature should be between 0.1 and 0.3. Top P will set it as 0.85. Frequency penalty and presence penalty will keep it as 0. The reasoning effort will send it to medium, and reasoning summary will set it to auto. Click on save. Come back to the main page of the AI agent builder, and you can see there is a add MCP server tools. Here we will select Playwright MCP server. This is the important part to note here. Like if you don't select this Playwright MCP server, it will not make use of the Playwright MCP server. It is important to add this MCP server here. If it is not provided, then it will not make use of the Playwright MCP server. And in return, you will see some text-based output generated as an output for your prompt. And we can click on save to save this agent. Let's talk about the instructions now. You need to provide a good amount of instructions to the AI agent, and so that it works exactly as you want. So I have defined a few instructions for the agent. It is like you are an expert QA automation engineer controlling a browser through Playwright MCP. Your goal is to execute browser actions safely and reliably. I have defined the tool usage, like it should not run all the MCP tools at the same time. Use only one Playwright MCP tool at a time and wait for the search results. Similarly, there are rules for navigation. It should treat the actions like clicking login, submit, continue for navigation triggering actions, and form submissions. Any action that changes the URL or reloads the page, after navigation actions, what it should do, like it should not call the DOM inspection immediately. I've also set up the rules for locating the web elements to take a fresh snapshot to inspect the current page. Then do not use the XPath locator strategy. Use the same field name to locate fields. Do not hallucinate and add prefix or suffix to field names. Use semantic locator strategy. This is most important because ideally the AI agent will start locating by using XPath or CSS selectors, whichever it finds easier. So we need to make sure it calls the correct MCP semantic locator strategies from Playwright MCP, like get by role, get by text, and so on. And do not use brittle CSS selectors. I have also set the interaction rules to verify and confirm that an element exists before interacting. And there are some rules for the error recovery as well, for checking the interaction rules, inspecting the current page, stop issuing new actions, retry only if the page state confirms it is safe. And there are some important instructions as well, like do not generate additional steps. Any deviation from these rules is not acceptable. So this is how you need to train the AI agent before you start using it. So ideally it performs the steps in a guided way. And we need to put the instructions in this instructions box here. Once we have done that, make sure you click on this save button to save the agent. Let's now see the AI agent in action. So first we need to select the AI agent from this model Qwen3 8B. Click on that in my agent and then select local AI automation engineer. And then let's rerun the same prompt that we ran previously. Let me copy it from here. Previously, we ran it on the model directly, but now we'll start a new chat. Select the agent to local AI automation engineer. You can see local AI automation engineer here, and then give this prompt. You should also see the agent name where it starts executing. So here I'm expecting it to open the Chrome browser and navigate to playwright.dev website and then verify the page title. It is important here to note that the more system resources are available, the more smoothly it will run. But since my memory is already maxed up, it will take some time to run these particular things. Also to note here, there are multiple instructions that I have given to the local agent. That is the reason why it will go through these instructions and accordingly perform the steps for execution. So let's wait for some time for this execution to happen. And we can see it opened the Chrome browser, navigated to playwright.dev, and we can see it used two tools, browser navigate and browser run code unsafe. It opened the Chrome browser, navigated to playwright.dev and verified this page title. We can see out the output. It prints the message, page title has been successfully verified. The page title is fast, reliable, and end-to-end testing. This is the page title, fast, reliable, end-to-end testing for modern apps. And it shows the test results. Step 1 is navigated to this, and step 2 is verified the page title matches expected value. No further actions required. Let me know if you need additional steps. This means that AI agent is accurately working as per the instructions that we had set with the correct model settings for the temperature, reasoning, and so on. Let's run another scenario where we will be navigating to the Parabank demo application and entering the username John, password as demo, clicking on the login button and verifying that the accounts overview page is displayed. Here I have provided some plain prompt where I have also instructed to locate the username field using name equal to username. This is just to make the things faster, because if I do not provide this, then it will decide the locator based on the XPath, CSS selector, get by role area, and it will take some more time. So it's better to provide a concise and crisp prompt to the AI so that it performs the necessary actions accurately. But if you want, you can also remove this, but at the same time, it will take more power, resources, system resources, and more time to execute the test. Let me quickly run this. Here I'm expecting it to open the Chrome browser again, and then navigate to this website, locate the username field, enter John into it, and then locate the password field, enter the demo password as demo, and then click on the login button and verify that the account's overview page is displayed. Like I said, it all depends upon the available system resources. If you have a good configuration system, then it will take lesser time to run. It will run smoothly and seamlessly. But since I have limited resources, that is the reason why it is taking a bit more time to execute the steps. At the same time, you can check out for the logs as well. You can see Playwright MCP server is running. This is the logs for LibreChat. It's already running and connected to the Playwright MCP. The Ollama serve is also running. This is actually running the model. Let's wait for the tools to execute the command. We can see it open the Chrome browser and navigate it to the website, Parabank. For each step that it executed, it shows us the details with the execution code as well, and how it executed. It's showing us the details of the code as well as the page details with the snapshot. The second step it should navigate is locate the username and password field and enter the values in it. So I think it is now thinking to locate the fields and perform a typing values into the field. Let's wait for it to run. So this did not succeed. It will try again. So it filled the value John into the username field using this page.locator. Now let's wait for the password. It filled the password also. Now it's the time for the login button. Let's see if it can locate that and click on it. Fine. It clicked on it. Now let's wait for the account overview verification. And we can see the note coming up here. The accounts overview page is successfully displayed. Page URL, page title, test step verified, no further actions required. And it shows a tick mark, which means all the steps passed successfully. Since I have not given the prompt to close the browser, it remains as it is. But if I had given the prompt to close the browser also, it might have closed that using Playwright MCP. But that is fine. I can close the browser manually. And you can see we used a natural language to execute these steps on the Parabank demo website, and Playwright MCP performed at its fullest to launch the browser, enter the username, enter the password, click on the login button, dashboard verification by checking the accounts view overview page, the title of that page, and all of these things were done using a plain prompt. We did not write any code, but Playwright MCP did the execution for us. Now let's learn why MCP is important. So without MCP, the LLM can only answer questions. With MCP, the LLM can actually perform actions. Think of MCP as the USB standard for AI. Years ago, every device had its own cable. Your printer had one connector, your camera had another, your keyboard used something different. Every manufacturer had its own way of connecting devices to a computer. It was frustrating because software had to be written specifically for each device. Then USB came along. Instead of learning how every individual device worked, your computer only needed to understand one standard, that is the USB. So once both the computer and the device supported USB, they could communicate seamlessly. It didn't matter whether you plugged in a keyboard, a webcam, a microphone, or an external hard drive. The same USB protocol worked for all of them. MCP does exactly the same thing, but for AI. Without MCP, every AI application would need to build a completely different integration for every single tool. If you switch from one AI application to another, you would have to rebuild all of those integrations again. That's a lot of duplicated work. With MCP, every tool exposes a common interface. The AI only needs to understand the MCP protocol. For a QA automation engineer, this is especially powerful. Imagine an AI agent that receives the request to read the Jira story, generate Playwright tests, execute them, analyze the failures, and create a GitHub pull request. Using MCP, the AI can read the story from Jira, access the source code from GitHub, generate Playwright tests, execute those tests in a real browser, save screenshots and log, commit the generated test back to GitHub, and update the Jira ticket with the results. Each of these actions is performed by different MCP server, but to the AI, they are all accessed through the same standard protocol. That's the real power of MCP. It's a common language that allows AI system to interact with an ever-growing ecosystem of tools in a consistent and scalable way. Instead of writing custom integrations for every tool, the model speaks one protocol. That's why Playwright MCP, GitHub MCP, and other MCPs work similarly. That's all for this video. If you found this tutorial useful, don't forget to like the video, subscribe to the channel, share it with your automation team. Leave your questions in the comment below. And thank you for watching.